The lesson topic for this video is multiplying rational expressions. So, there's what I like to call the long way and the short way to multiply rational expressions. And you learned this back when you learned about just multiplying fractions in elementary school. So, multiplying fractions can be done simply by multiplying straight across the numerator and straight across the denominator. So, remember, this is not cross multiplication. Okay, we are not cross multiplying. That's only what we do if there's an equal sign here, which there is not. So instead we just multiply the numerators. 14 times 15 is 210, and 25 times 21 is 525. Okay, but we know that this result is not simplified. It is not in the most simplified form it could be. So then what we need to do is we need to think about what 210 and 525 are both divisible by. If you think for a second about 210 and 525, you might know right away that they're both divisible by 5. So, okay, let's divide the top by 5, and let's divide the bottom by 5, and our result is 42 over 105. But what you might notice here is that 42 and 105 are still both divisible by the same number. We can still simplify this fraction because they're both divisible by 7. 42 divided by 7 is 6, and 105 divided by 7 is 15. You might not have even noticed that, but they are both divisible by 7. So now we have 6 over 15. And 6 over 15 is still not simplified fully because they are both divisible by 3. So now if I divide by 3, I'm going to finally arrive at my most simplified answer. 6 divided by 3 is 2. And 15 divided by 3 is 5. So our final result is finally 2 over 5. Now option 2 is a shorter method for multiplying fractions. And what that is we simplify the fractions first. It's kind of like remembering to factor out a GCF first when we're factoring because it makes the problem quicker and more simple. Same thing here. Remember that we can simplify fractions both vertically, just the same fraction can be simplified, but we can also simplify fractions that are being multiplied by simplifying values that are diagonal from each other. So what we can do right now is we can think about how 14 and 21 are both divisible by 7. So if I divide 14 by 7, I get 2, and if I divide this 21 by 7, I get 3. You might also notice that the 25 and the 15 can both be divided by 5. If I divide both of those by 5, 15 divided by 5 is 3, and 25 divided by 5 is 5. We still can simplify further because we also could see that this 3 over 3, well, 3 over 3 as a fraction is 1, because 3 divided by 3 is 1, and 3 divided by 3 is 1. Finally, we arrive at our final answer here. 2 times 1 in the numerator is 2, and 5 times 1 in the denominator is 5, and we get 2/5. Again, same answer. I would personally suggest that you use option 2 because it is a quicker method for multiplying fractions. Now let's see how this works with our rational expressions we've been working on in class. So here's what we want to do when multiplying rational expressions. We want to first factor everything. Everything possible that can be factored, whether it's a GCF, a quadratic where a equals 1, a quadratic where a equals something other than 1, or a difference of squares. We want to factor all of these things before our next step. Our next step would be to look for ways to make 1. And I've been talking about that as well recently. Sometimes we use the word cancel or cancel out, looking for terms that cancel out. And after we're done with all of that, we're going to multiply straight across the top, the numerator, and straight across the bottom, the denominator. Now this first example I actually factored already for you. So this is in completely factored form. I factored out 2x out of an expression, and I got 2x times x plus 8. X plus 1 is up here. In the bottom, in the denominator here, I factored x squared minus 5x minus 6 into these two terms, or two factors. And then I factored out an x here. So I already did that factor everything first for you. Now I want you to practice looking for ways to make one, or in other words, canceling things out. Remember, as long as something is a common factor in the numerator and in the denominator, it can be, again, canceled out or makes a 1. So this x plus 1 is the first thing I noticed. There's an x plus 1 in the numerator, and there's also an x plus 1 in the denominator of this fraction. So they can be divided, which makes a 1. Divide this, and we get 1 over 1. Is there anything else we can cancel out or make a 1? Well, this x right here and this x can be canceled out because x divided by x is 1 over 1. Anything else? The answer here is no, there's nothing else. Be careful. This is x plus 8 here, and this is x minus 8. They cannot be canceled or simplified. So what we're left with in the numerator, if we just multiply straight across the top, we have 2 times x plus 8 times 1, and that's it. So we have 2 times x plus 8. In the denominator, we have 1 times x minus 6 times 1 times x minus 8. So we have x minus 6 times x minus 8. This is our final answer when we multiply those fractions. Okay, so for this example, it's similar to the previous slide, but this time I did not already put the numerators and denominators of each fraction into factored form. I haven't done my factoring. So that is our first step. Again, step 1, factor everything we can factor. Okay, so in the numerator of our first fraction, you should notice that we can factor out a 2 and an x. When we factor out a 2 and an x, we are left with x plus 2. Again, the 2 is factored out. One of these x's is factored out. We're left with an x. The 4, the 2 is factored out, which means we're left with a 2, and this x was factored out. Okay? In the denominator of this fraction, I notice right away that this is an a value of 1, which means we only need one step for factoring, and it's the two sets of parentheses. We know it's going to be x times x, because x times x gives us the x squared. And if we want to write down that c value over here and think about what factors of negative 12 there are, that when we add them we get negative 4. Some of you probably are going to list all of them out every time. Some of you are finding that you can find the correct factors without writing them all out. What you should notice is that it should be a positive 2 and a negative 6 for our two factors, because this will add up to negative 4, which is our middle term. So plus 2 and minus 6. The numerator of our next fraction also has an a value of 1, so I'm going to put my x for my factors here. I'm going to write my 18 off to the side. 1 times 18, or 2 times 9, or 3 times 6. Well, 3 plus 6 is 9 right here, but we need a negative 9. So we know that both of these need to be negative, because a negative times a negative is a positive 18. So our factors are x minus 3 and x minus 6. In the denominator of this fraction here, 2x is already split into just two factors, 2 and x. After we factor, we make 1. Okay? And again, another way of saying make 1 is cancel things that are common factors. 2 divided by 2 is the first thing I noticed, which is 1 over 1. And the x next to it, and the x here, also cancels or makes a 1. The x plus 2 right here, I have an x plus 2 in the denominator, so I can cancel x plus 2 with the x plus 2 because it makes a 1. I have an x minus 6 right here and an x minus 6 in the numerator here, so again, that makes 1 over 1. And the only thing left in the entire set of fractions is this x minus 3 here, and we can't cancel that or make 1 with anything. At this point, we're ready to write our final answer. If you look, again, very carefully through the numerator, this has been canceled into 1s here. We've got an x minus 3 This has gone here and made a 1, made a 1, made a 1, also made 1 here. This is our final answer, x minus 3. If you wanted to put that over 1, x minus 3 over 1 would be a fine answer as well. Okay, two more examples multiplying rational expressions. If you take a look at both of these, you'll notice that there's some factoring to do in number 3 in the numerator and a denominator for each. And in number 4, you'll notice that there is nothing to factor here, but this is a difference of squares, so keep your mind on difference of squares as well. And then I want to point out that when you've got something like this and there's no denominator, well, there is always a denominator. So if you want to immediately make this over 1, you can, because that is what it means. So now we've got our fraction. All right. You might want to pause the video, try these out on your own and see how you're doing with this. If you'd rather watch me, that's fine as well, but make sure you go through them one way or the other. In number 3, we're going to factor out a 6 and an x, and we're left with x plus 3. In the denominator, we have a equals 1, so we're going to go ahead and factor this down. We've got a negative 6 to think about our factor pairs, 1 times 6, but one of them has to be negative, or 2 times 3, and one of them needs to be negative. This factor pair adds up to 1, which is what we need here, positive 1. So our factor is x minus 2, and the other factor is x plus 3. In the numerator of the next fraction, again, a is 1, so we're just going to go ahead and put an x in front of each, do our quick factoring method. Negative 2 is 1 times 2, but one of them needs to be negative. Notice this is not the correct number that we need negative, because we needed to add up to negative 1. So I switch those around. We have x plus 1 and x minus 2. The last one also needs to be factored. Notice we need to make the 1 positive and the 8 negative in order for these to add up to negative 7, which is what we need for our middle term. X plus 1, x minus 8. Everything is factored, and now we can start making 1 or canceling. X plus 3 with an x plus 3, an x minus 2 with an x minus 2, an x plus 1 with an x plus 1. That's it. Our final answer for this one is 6x in the numerator is all of the factors that are left. In the denominator we have x minus 8. That could be in parentheses or not in parentheses. Either way, it does not matter. Again, notice that since this is a binomial factor, we cannot cancel the 6's, or x's, excuse me, and we can't simplify the 6 and the 8. This is stuck together, and it can only be canceled or changed if the whole thing is canceled. All right, last one today. X minus 4 is in factored form. It's a binomial factor right here, and it's fine and simplified. In the denominator, remember x squared minus 1 is a difference of squares. We can put an x here and an x here. The 1 is 1 times 1, and we need a positive and we need a negative. In the numerator over here, a is 1, so x times x. 1, the only factors of 1 are 1 and 1, but they're both going to need to be negative in order to get negative 2 for our b term. So x minus 1, x minus 1. And x minus 1 cancels out with one of the x minus 1s. Please notice, first of all, I can't cross this out here. Notice that if one of my x minus 1s cancels with this x minus 1, I can't cancel both of the x minus 1s unless I've got 2 x minus 1s in the denominator, which I don't. So it doesn't matter which one you cancel out. We just have one of them remaining. All right, so then what we have in the end is x minus 4, and now we do need to put that in parentheses because next to it needs to be the x minus 1. And in the denominator we have x plus 1, again, with or without parentheses for that one would be fine.